Okay, so hi everyone. This video will give you a short introduction to the empirical rule. So this empirical rule is a shortcut, or not a very detailed um, showcase of what we call the normal distribution. It is all about the bell-shaped distribution, the bell-shaped curve, the symmetric shape of the one of the shapes of the distribution, which is a special one where the mean is equal to the median, and it's also called as the normal curve or the Gaussian curve, right? So for the empirical rule, when the data are believed to approximate a bell-shaped distribution, the empirical rule can be used to determine the percentage of data values that must be within a specific number of standard deviations of the mean. So we can see it in this illustration that, say you have the mean over here, right? So your measure of spread is actually as we learned, it's the standard deviation or the measures of variation or dispersion. So if your data is normally distributed, it is guaranteed that whatever your mean is, that's going to be your central value or central tendency there. If you're going to have one standard deviation below and above the mean, so whatever your value is, you're gonna minus one and one. You're gonna minus and plus one SD. You are guaranteed that 68% actually of the data falls below that or between those numbers. Again, if you have your mean value and you have an SD and you know that it's normally distributed, you add and subtract one SD from that mean, and therefore you are guaranteed that 68% of your data fall within that interval. For the 2SD, if you're going to plus and minus 2SD from the mean, you are guaranteed that 95% of the distributions or 20%, 95% of the data fall between that interval. And if you're going to add and subtract three standard deviations um, from the mean, it's going to tell you that it's 99.7%. The data, all of your data, 99.7% falls within that range. Okay, so that's simply the message of the empirical rule. So if we're going to see an example, say we will have this. Liquid detergent cartons are filled automatically on a product line. Filling weights frequently have a bell-shaped distribution. If the mean filling weight is 16 ounces and the standard deviation is 0.25 ounces, use the empirical rule to draw the conclusions about the distribution of filling weights. So say for example, we will have this mean as 16, standard deviation as 0.25 ounces. Right now, let's try to hide the units for easier, for easier um, communication. Uh, I use this pen. And we know that the mean is 16. I'm gonna put 16 out here. And that's your mean, right? So that's your mean number. That's your median number as well. So if you're going to add one SD there, it's going to become 16.25. So we're going to put here 16.25. Okay. And if you're going to minus 1 SD, it's going to become 16, minus 0.25. It's going to become 15.75. Let's write it down. That's a decimal point. Can I undo that? To erase. Okay. 75. So the thing with this, given the empirical rule, it tells us that 68% of the data points lie within 15.75 ounces and 16.25 ounces. So that's 68% of all the data that you have. So if you're going to add more, if we're going to go beyond the 1 SD, so 16 plus twice this SD, that's going to be zero point 0.5. So it's going to become 16.5, right? This one, on the other hand, becomes 15.5. Okay, so meaning 95% of the data, all of the distributions, fall between 15.5 and 16.5 because that's what the empirical rule says. If we're going to add another SD, so 3 SDs, 0.75, that is going to become 16.75. 16.75, and this one becomes 15.25. All right, so how do we interpret this? 99.7% of the data are within three standard deviations of the mean. So if we're going to convert it in actuality, this becomes 99.7% of the data fall within 15.25 ounces and 16.75 ounces. Let's have a trick question. Okay, how many percent of the data fall within 16 to 16.75%? Or sorry, 16 up until 16.75 ounces. How do we know that? So you answer this since we know that 3SD is 99.7. You divide this by 2 because that's actually just half of the 3 plus minus SD. So 99.7 you divided by 2, it's going to become what? Um, 40, what, 44 or 49.6, right? Make it no, 49.3 or point 0.4 rather. So that's going to be the answer right here. Okay. So since this is 100 minus zero point 0.6, so that's going to be 49.4 for this one. Another trick question. How many percent fall within from 16 going to 16.5? So this is 2SD, right? So 2SD, you divided by 2 because it's only half of the 2 plus minus 2SD. So what you have is 95 divided by 2. It's going to become what? 47.5. Another one. What if I'm going to ask you what percent of this will fall within this part? Okay, only this part over here. So using the empirical rule, we can get that. We need to get the value first of this one. So this is as we can recall 49.4. You minus that with 47.5, and whatever the result is, this is the answer for the x. So hopefully you got that because this question will come out of the quiz. Okay, so thank you very much for listening. That's it for this video for the empirical rule, and that's the end for the measures of variations as well. So thank you very much for listening, and I hope you learned something today. Thank you.